Okay, in this video we're going to continue with soft bodies and we're going to focus on performance in this video because soft body simulation can be slow or it can be fast depending on how you set up your performance parameters. So let's go ahead and do that. Let's select the soft body sphere. We'll go to the selection button in the MCP and we'll click on the little icon here that's to the left of the soft body op to open up its PPG. Okay, so here's the property page again for the soft body operator here. And we've already gone over all these different things except dynamics. We'll go over that pretty soon. And then we went over soft body, but we didn't go over the simulation tab here. And this tab is going to directly affect the performance of the simulation. Okay, first parameter here is mute, which is off. If we turn that on, obviously that's going to turn off the simulation. So it's great for if you're doing some testing, if you're testing other simulations and you don't need to waste time or resources simulating this one. So you can mute it temporarily and then unmute it. Okay. Here we have some range parameters as well. Now these range parameters are going to tell the system what frames to go ahead and take and calculate. Unlike rigid bodies where you have to go ahead and simulate the entire timeline or else the rigid body won't move, soft bodies work a little bit differently. Right now this is set to 1 and 200. So the start frame of the simulation is 1, end frame is 200, and that is not good. I'll tell you why the reason is that that's not good. The thing with simulation is that you don't have to simulate the whole timeline. It's best to simulate only what's actually being simulated. So what do I mean by that? Well, if we go ahead and hit play, simulation starts at frame 1, the object splats down, and by about frame 50, I would say, the object is no longer simulated. There's no reason to simulate it anymore. It's splatted onto the ground. It's not moving anywhere. I'm already past frame 200. There's no reason why the system should be wasting resources calculating from frame 1 all the way over here to 200 if the simulation really isn't doing anything past frame 50. So the smart thing to do would be to set up the start frame at frame 1 because we want it to start simulating at frame 1, but put the end frame to frame 50. And what that's going to do is if we hit play, it's going to go to frame 50 and then it's not going to simulate anymore. Now because the object already splatted, it doesn't make any difference if it continues to simulate past frame 50, because even if we had it simulating past frame 50, it really wasn't doing anything to begin with. So this saves us resources, it saves us calculation time, and it gets us moving along a lot faster. We can use these buttons to copy the start frame and end frame from the scene. So for example, if for some reason I wanted to simulate from frame 1 to 500, which is what I have here in my scene, I can click on copy from scene and it'll do that. Again, that's a huge waste of resources because the object really isn't simulating past 50, so there's no point in having the system calculate all the way to 500 frames. Okay, so I'll switch this back to 50. If I click on this copy to scene button, what it'll do is it'll change my scene time from 1 to 50. So it takes the time that I inputted here in the range parameters and it'll go ahead and copy that to my actual scene, which in this case is not what I want to do. So I'll switch this back to 500. So this is a way of optimizing it very efficiently. Down here we have an iterations per frame parameter. Right now it's set to 25. This is a very important parameter. The lower this parameter is, the faster the calculation will be. However, the lower it is, the lower the accuracy. So if you see that you're having some kind of problems, the object is not simulating correctly, it doesn't look very accurate, it's doing weird things, you might want to increase these iterations, and you might want to increase it one by one. Then test the simulation, see what happens. If you're still not getting the results that you want, just increase it by another iteration per frame and try it again and again and again. The idea is to tweak it to the point where you get to the max amount of iterations that you can get to while keeping good quality simulation results. So you don't want to increase this all of a sudden to say 43 over here, because if this object can be simulated perfectly fine at as low as say 6 iterations, there's no point in making this thing calculate 43 iterations per frame. You're really wasting time and resources. So it's a good performance boost and it's a good parameter for controlling your performance versus quality. And then you can save the simulation. If I have this checked on, When I close XSI and I reopen it, say tomorrow or whenever I'm going to work on this scene again, if I had this checked on, XSI would save the simulation to the scene. That way when I open up the scene and I hit play, it doesn't have to calculate over. It just already picks up where it left off the day before or an hour before or the last time you worked on the scene. If I turn that off, the next time I open XSI, when I hit play, XSI will have to go ahead and calculate the simulation again, which could be a problem if it's a complex simulation that takes a long time to calculate, as you can imagine. Last but not least, we can also plot the animation of this object. We can plot the deformation. So what am I talking about? Well, let's go ahead and lower this back down again. Something like that. Let me go to presets and I'm going to give it the rubber ball preset. I'm going to close that property page and I'll hit play. It calculates. There it goes. And there it goes. It's falling down and it's going to perform like a rubber ball. Perfect. Just going to let it simulate. And you can see it's going pretty slow. XSI gives us the ability to take all that data, all that animation information that's being calculated now in real time, and I'll hit stop, and now if I hit play, it plays very quickly. Okay? What you can do is do something called animation plotting, also known as animation baking in other software, which allows us to take all the information that's going on here, the bouncing, the movement of the rubber ball, and output it to an animation file that we can refer to. This way, XSI no longer has to calculate the simulation and can just refer to the animation file to go ahead and create the animation, which is obviously much faster than calculating this over and over again. So how can we do that? Well, we'll have this object selected. What we'll do is we'll switch from the Simulate menu to the Animate menu. Under the Tools menu down here, when you're in Animate mode, we'll see this button that says Plot. So go ahead and click on that. And you see that we can plot all kinds of different things. Positions, rotations, we can plot all transformations, and all kinds of things. The one we're interested in is the Shape mode over here. So we'll click on that, and a PPG will open up, and XSI will ask us some information here. It wants to know what you want to call this new shape name. So I'll call it my bouncing ball. And I'll tell it to the shape content to be all deformed. So all of these default options are perfectly fine. Now it's also asking me what frame range to copy the animation from. So it can be from frame 1 to 500. And I believe the simulation ended past frame 200. I know it doesn't continue to frame 500. So what I'll do is I'll probably just go to 250. And then I'll hit OK. And it went ahead and saved out the animation. Alright. So now I can take this object. I can go over here to selection. I can take the soft body operator here. And I can delete it. So I'll hit delete on the keyboard to get rid of it. So now it's gone. So now I don't have any type of soft body simulation going on. However, because I plotted out the simulation to an animation file, it'll continue to work. And to see that, let's select the sphere and we'll hold down Alt and hit 0 on the keyboard. And you can see that this opens up the animation mixer. And I can see this blue file here, which is a shape file, or a shape mixer shape file. And you can see here it's called My Bouncing Ball, and it's a clip. It's an animation clip. Essentially, we took all that data, all those mathematical calculations that the simulation engine performed earlier, and we turned it into an animation clip, which is a very simple data file that doesn't take a long time to calculate. It's an animation clip, is what it is. So now we could take this animation clip and we can use that instead of simulation. That way, the system doesn't have to calculate and simulate over and over and over again. It doesn't have to simulate anything at all. We can just go ahead and play back from that animation clip, and our performance boost is going to be immense. So no more calculations. Everything's being brought in from this animation clip. So it's another way of increasing the performance here of our scene. Then you can get rid of all that simulation stuff and the soft body operator, and all the objects in your scene will continue to bounce or splat or do whatever it is that you made them do without having to calculate a thing. So it's another way of increasing your performance in exercise using soft bodies. Okay, so that'll do it for this video on optimizing and controlling performance when working with soft bodies in exercise and cutting down that calculation time, in some cases, like in this case with plotting, completely. Okay, so that'll do it for this video. I'll see you in the next one. Take care.